Okay, students, so we can start now. Today we will discuss about the KAH circuit, how to solve KAH circuit. And in this lecture, we will see what a Ohm circuit, the limitations of Ohm circuit, and the advantage of KAH circuit. If we consider a Ohm circuit, which we have discussed on our SSC during our SSC time, at that time we can see that Ohm circuit can be used for one cell. In fact, you can say that it is used for one cell. But if we consider more than one cell, then at that time the Ohm circuit has some limitations for it. Because if we have more than one cell, that means 2 cells, 3 cells, at that time Ohm circuit could not detect those current which is going to that circuit. So for this reason, KAH circuit is necessary. Kirchhoff's equation and Kirchhoff's law is necessary to solve those circuits. So this is the main reason we should go for KAH circuit. So first I am drawing a normal simple circuit. If I say it's a normal simple circuit, then a simple circuit consists of a resistance, a cell, and in this circuit, if I want to get the value of I, we can use the Ohm's law and we can use this equation to determine the current from this circuit. If it is capital R and if it is smaller and the electromotive force is E. But if you are given just like this, 2 cells, suppose 2 cells are given, at that time Ohm circuit is limited because Ohm circuit could not detect the current all the time when we connect more than one cell. So that in this section, KAH circuit is necessary, or Kirchhoff's law is necessary. So here we will discuss how to solve a circuit which is more than one cell according to Kirchhoff's law. So first, I am going for this circuit, but I am giving some values here. I plot 6 ohm resistance here and internal resistance as 2 ohm. Also, I am giving here a 12 volt battery and a 2 ohm resistance for a 9 volt battery. And I am indicating some current here. This is current I1, and for 9 volt, this is current I2. So if these two current goes at this point, suppose I am considering this is A, this is B, this is C, this is D, this is E and F. So if I consider the point A, then I can see that for point F, I1 current and I2 current is coming towards it, and another current goes away from it. So I can say it's another current I, which is go away from it. But according to Kirchhoff's law, I can say at point F, I as I1 plus I2. So this may be our first equation. This is our first equation, where I get the current I, the addition of two currents I1 and I2. Okay, then I am going for the second Kirchhoff's law, which says that the product of current and its individual resistance, if I summation all of this product of current and resistance, we will get the electromotive force of the circuit. So according to Kirchhoff's second law, we can go for some loop or enclosed circuit. So if I go just like an enclosed circuit of A, B, C, F, A. Suppose I am going for A, B, C, F, A, this circuit. So we have to remember one thing. If the current goes the direction I go, the current I will consider as positive. I am repeating again. If the current goes in the same direction where I am considering, then the current is considered as positive. And if the direction of current is opposite to the direction where I go, or I am going towards that loop, then the opposite current will be considered as negative. So we'll go for this map. First, I am going for AB direction, and the current is also going for AB direction. So 6 into I, it means 6I. Again, I am going for BC direction, and also the current I goes towards BC direction, but on the BC section, there is no resistance here. So if there is no resistance, we will consider that path, we can ignore that path in fact. So I into 0, that means we can ignore this path. Now, the second, third path, which is CF. So if I go for CF, on this part, current I is divided into 2 again. This is the region of I1 current. So if you see the CF, you can consider here the current I1 is going towards it. So I1 current goes with 2 ohm resistance. So I can place 2I1. And finally, when I reach from point F to A in this section, there is current I, but there is no resistance here. So I can ignore this part. So I can say when I go from point A and after starting from point A and reaching to the point A again, then I can say 6I plus 2I1 is equal to, there is a cell included on it, it's 12. So this is equation number 2. So in such a way, I can make a loop and I can go through it. And after that, I can make an equation from it. Okay, so this is for one loop. Again, I can go any loop of it. If I go for the second loop as A, B, D, E, A. A, B, D, E, A. So again, the same path, A, B, D, E, A, I am going for the same system. The direction where I go, if the current goes in the same direction, I can consider current as positive. And if the current goes in the opposite direction, I can consider the current negative. So if I go for AB and current I goes from 6, so it can be 6I for AB. If I go for BD, the second path is BD. There is no resistance included in it, so I can ignore the whole path here. So BD is ignored. Again, I go for DE. Here, the current I2 goes from this region because the current, this is the region of current I2. So I2 current goes with 2 ohm resistance, so I can say it's 2I2. And the last, I have EA. If I see EA, there are currents, but there are no resistance here, so I can ignore that part. So overall, if I go from A and then I reach at the point A again, there is one cell that I have included in it, that is the battery 9, that is 9. So this is equation number 3. So these 3 equations are more important because if you get all of these 3 equations, then you need not to observe that circuit again. You just solve that equation and there you will get the current easily. So if I ask to get the current I1, I2, and I3, you just make these 3 equations. 2 loops and one Kirchhoff's first law, which current goes and which current comes. So if these three equations are made, then you need not to see this diagram. You just solve these three equations. Then you can get the answers. Okay, so first, how we can make from 2 and 3. If I subtract the equation 3 from 2, I can say this one, 2I1 minus 2I2 is equal to 3. If you subtract equation 3 from 2, then 6I will be vanished due to subtraction, and 2I1 minus 2I2 will be 12 minus 9 equal to 3. So you can say that it's equation number 4. This is equation 4. And you can recall an equation. Recall means here I is the summation of I1 and I2. And this I has some equations on 2 and 3. So if I express this I current in terms of I1 and I2, then I can make another equation. That's why I'm saying it is recall equation. So the recall equation of 2 or 3. Any equation you can recall. So I recall equation 2. So if I recall equation 2, it's 6I. So I is here I1 plus I2 plus 2I1 is equal to 12. So I can convert I into I1 and I2. So 6I1 and 2I1 makes 8I1 plus 6I2 equal to 12. This is equation number 5. Now, if I solve these equation 4 and equation 5, I can get the value of current I1 and I2. So I think you can solve this equation 4 and 5 now. Solve it. Equation 4 and 5. It's an easy one. If you multiply equation 4 into 3 and then you add equation 5, you can get one value of it. Multiply equation 4 into 3 and then add equation 5. So if I multiply equation 4 into 3, I can say it's 6I1 minus 6I2 is equal to 9. And if I say the rest one 5 equation, 8I1 plus 6I2 equal to 12. So if I add this, 14I1 is equal to 21. So I1 will be 1.5 ampere. 1.5 ampere. So this is the value of I1. And if I get the value of I1, I can also get the value of I2. Plot the value of I1 in equation 4. You will get the value of I2. Okay, so what will be the value of I2? Anyone?
0 আসে স্যার
0. It may be 0. It may be minus also. So don't get confused. It may be 0, it may be minus. So when the current, you have solved the equation, it may be positive, it may be negative, or it may be 0. So in this circuit, we assume that a current flow I2 towards this region, but actually there will be no flow of current. And that is the answer. The result says this thing, that there will be no flow of current towards 9-volt battery. And if I get the negative, suppose if you get the current I2 as, suppose, is minus 1 ampere. If you get like this,
get like this.
2 as minus 1 ampere. This minus represents that the way you are imagining where the current I2 goes, actually I2 goes in the opposite way. That's why I2 has a negative value. So when you get the negative value, you have to remember one thing, that the path we have decided that the current goes through on it, actually the path of that current is in the opposite direction. That's why you have got the minus current. So this is the thing. If you get minus current, so you need not to bother about that. Current may be positive, current may be zero, current may be negative. Anything can be happening. Okay. So now I am giving you one circuit, and I will help you to do some of it, and then the rest of it you will solve. Okay. So now I am giving just like this.
স্ক্রিনটা ব্লার হয়ে গেছে স্যার।
ওকে, আমি ঠিক করতেছি, 1 মিনিট।
ঠিক আছে স্যার।
ওকে, অটো ফোকাস তো মাঝে মাঝে এরকম একটু ডিস্টার্ব করে, আর আমি এটা ল্যাপটপে না, এটা আমি তোমাদের মোবাইলে পড়াচ্ছি। Okay, if you look into this picture, this diagram, it is also a Kirchhoff circuit. There are two cells on it. I am considering here as I1, and I am considering it as I2, and I am considering the current as I, and it is 5 ohm, it is 2 ohm, it is 6 volts, it is 8 volts, and it is 3 ohm, and it is 4 ohm, and I can make it as 6 ohm. So these are the different resistors that I have included in it. Now you will go for these three currents, I1, I2, and I. This is the question: what is the value of I1, I2, and I? So this is the question: I1, I2, and I. So if I go for this circuit, I have to do first equation. The first equation, which is Kirchhoff's first law. So first you have to do some points indicate on this circuit, and you can name that A, B, C, D, E, F, just like the previous one. And then if you look at point B, you can see that I1 current goes towards it, I2 current is also coming towards it, but I current goes away from it. I1 is coming, I2 is coming, but I is going away from it. So the first equation is necessary. Here I can say I as I1 plus I2. So this is the first equation. The first equation I can make here from this circuit as I1 plus I2. Okay, now for the second. For the second equation, I will go for a loop. And if I go for a loop here, such as A, B, E, F, A, any path you can choose. You can also choose B, A, F, A, B. But if I go for the current direction path, that will be easy for us. The equation will be slightly easier. So I am going for again A, B, E, F, A path. So now I am going to AB path. Current is also going in the same path, so it's 5I1. Okay, then plus. I am going to BE path. Current I goes towards 6. That means it's 6I. Then at point E, this current is also divided into two. I1 goes towards the circuit, and I2 goes this circuit. So if I say that for EF section, you see that there is no resistance here. So we don't need any information here. We just ignore this part. So EF is ignored. And the last one, if I say I1 current goes through F2A direction, then I1 is going under the 4 ohm resistance. So I can say it's 4I1, I1 with 4I1. And the total whole path or the whole path contains an electromotive force which is 8. So I can make an equation which is 9I1 plus 6I is equal to 8. So this is equation number 3. If you can make these three equations, then the circuit will be very easy. But if you make some wrong information while you solving this circuit in equation 1, 2, or 3, then the whole result will be changed. So you have to consider that 3 equation, that will be the perfect one. So now we will go for CBEDC. CBEDC, if I go for CBEDC. So first I'm going to CB direction and I2 current goes towards 2. So it's 2I2. It's 2I2. Then if I say the BE path, current I goes with 6 ohm resistance, so that I can say that 6I. After that, I can also ignore the ED path because there is no resistance included in it. So the path is ignored. And the last path, here I2 current, because it's the I2 current path. I2 current flows under 3 ohm resistance, so it's 3I2, and the electromotive force is 6. So therefore, I can say it is as 5I2 plus 6I is equal to 6. This is equation number 3. So I have made the 3 equations, and then I can make the equation 4 as well as the equation 5, and after that I can solve this equation. So how we can make equation 4? By subtracting or adding, any of you can do, but you have to decide which one you will do. 2 minus 3. So I can say 9I1 minus 6I2 as 2. So this is equation number 4. And if you recall any of equation 2 or 3, just like now I recall equation 3. If I say it is 3 number equation, which I recall, that is 5I2 plus 6I. What is I here? Actually, it's I1 plus I2 is equal to 6. So I can say it's 11I2 plus 6I. 6I1 is equal to 6. 11I2 plus 6I1 equal to 6. So you can further say in this way, 6I1 plus 11I2 equal to 6. This is equation number 5. Now solve equation 4 and equation 5. You will get the value of I1 as well as I2 as well as I. Now solve these 3.
Sir, equation 4 with a 5I2 होगा ना sir?
One equation?
Equation 4 sir.
Equation 4.
Sir,
Yes,
minus
yes.
5I2, sir. Minus 5I2.
5I2. Yes, it's 5 minus 5I2. Okay. Now solve this equation 4 and equation 5. Yes, that is minus 5I2. আমি mistake 6 লিখে ফেলছি. Okay. Now we'll go for equation 4 and 5. Solve these two. And if you multiply equation 4 by 11 and 5 by 5, then you can get the value of I1. Multiply equation 4 by 11 and equation 5 by 5. You will get the value of I1.
So 0.403 আসে নাকি কারো?
Wait.
Yes sir. 0.403 I1.
I1 is 403.
Yes sir.
Okay, if I1 is 4.403, then you can also get the value of I2. Solve it. .403 is the right answer for I1. Yes, all of you are correct. 0.403 is the right answer for I1. Now solve it for I2.
0.3258 আসে কারু?
0.3258.
জি স্যার।
Okay,
Yes,
let
sir.
me
3
check.
to 5.3258.
Yes, 0.325. 0.325 ampere. Okay. So if we have the two current I1 and I2, if I plot the value of I1 and I2 in equation 1, I can get the value of
আই
I1.
স্যার আই মনে আছে 0.728 আসার কথা।
I1,
আই স্যার আই।
I. Yes, I will be 0.403 and 0.325. So it will be 0.728. Good. So I is 0.728. Okay. If you are asked to get the voltage or to determine the voltage to BE section, suppose if I say just like this, what is the voltage on BE section? What is the voltage on BE section? If you are given this type of question. So if a voltmeter you can place here, you can use a voltmeter equation here, that is V is equal to IR.
4.36
What you have got I as 0.728 ampere, and it is multiplied by 6 because the voltmeter across the resistance will give the voltage of only those parts. So what will be the total voltage here?
4.368 স্যার। ভোল্ট।
4.368 volt. So if I say what is the voltage on BE section, you can say it is 4.368. Okay, if I say what is the voltage on BC section, how you can explain that? What will be the voltage on BC section?
So I2 into স্যার 2 ওহম হবে।
Yes, it's obviously I2 into 2, and finally you can say the voltage also. Tell me about how you got about the voltage on BC section.
The 0.65.
6516
0.65.
The current was 0.325 into 2, right?
yes sir
0.65. 0.65?
16
Okay, 0.65. So the every section voltage can be determined by using this law. V is equal to IR. So if I measure the current from this circuit, I can solve the circuit. And then I can get the voltage of the circuit. Good. Now I am giving you another math, but now this is up to you. You have to get all those three equations, and then you have to make equation 4 and 5 from it, and after that you have to determine all of the currents. So I will go for equation just like this. Okay. So if you look at the right section, the battery is slightly changed the direction, the opposite direction I have placing the battery now. So you have to decide whether the current will flow, which direction the current will flow. So first you decide just like, you can decide any way of current, any way. It's up to you. But most commonly or generally, we will give the direction from positive end to negative. Generally, we do that. So if I say this is I1, because the current goes from positive. And if I say generally say it is I2, then the current goes from the positive direction. So first as we know that current goes from positive end to negative end, that's why we give the direction of I1 and I2. Okay, so here I1 comes and here I2 comes. Now what? Which direction the current will flow? Just give any direction of it, any direction. So suppose you are giving this direction the current will flow. This is the third current I. You need not to decide which way, and you need not to be confused also. Either it is right or wrong. No, you just give the current direction at any way you can decide. Now go for the path. A, B, C, D, E, F. So if I make all of the points, then I can make some loop. And first, I can go for the first equation, which is used by Kirchhoff's first law. If you go for point B, you can say that I1 current is coming, I current is coming, but I2 current is going. This is the I2 circuit, current is going again at the negative end. So now the equation is slightly changed. I1 is coming, I is coming, but I2 is going. So I can make the first equation just like this. I2 as I plus I1. Because if I look at point B, I can see that I1 and I are coming, but I2 is going. So I can make the equation just like this. I as I2 minus I1. So this is equation number 1. Okay. Now you go for the loop. Now you go for the loop. The first loop, A, B, E, F, A. A, B, E, F, A. Okay. I am going A, B, current goes also A, B, but there is no resistance, so ignore it. Then B, E. I am going B to E, but current goes in the opposite direction, so it's minus 8I. Again, E, F. So here current I1 goes from this end to this end, E to F. So it's 5I1. And also current I1 goes from this end to this end with 2 ohm resistance. So it's 5I1, 2I1. And finally we have got a voltage of it, it's 4. So according to this path, I can say it as 7I1 minus 8I is equal to 4. This is equation number 2. And now you can go for another path. Which path? D, E, B, C, D. D, E, B, C, D. So you start from now here. You are going from this path. I2 current is also going from this path. So 7I2. Okay. Then you are going for EB path. Current is also going for EB path. So it's 8I. You are also going from BC path. Current is also, but there is no resistance. So ignore that path. And the last path, I2 current flows with 3I2. And this is 6. So finally, I can make another equation for it, which is equation number 3. 10I2 plus 8I is equal to 6. This is equation 3. Now you can solve this, the rest of it, and tell me the answer. Just add equation 2 and equation 3, you can make equation number 4, right? If you add these 2 and 3, 2 plus 3. So you can make the equation 4. 7I1 plus 10I2. 7I1 plus 10I2 is equal to 10. So this is equation number 4. 7I1 plus 10I2 is equal to 10. And recall any of equation. Any equation you can recall. 2 or 3. So I recall equation 2. So if I call equation 2, it's 7I1 minus 8. What is I here? I2 minus I1. I2 minus I1 is equal to 4. So it will be minus plus 15 I1 minus 8 I2 is equal to 4. This is equation number 5. Now solve these two and you will get that. Tell me that. If you solve equation 4 and 5, you will get I1 and
Sir,
I2.
I1 equal to 0.582.
I1
Yes, sir.
is equal to
0.582.
0.582. Okay, so it's 0.582 ampere. And what is I2?
0.59.
0.59. Okay, so what is I here?
9.7 into 10 to the power minus 3.
Okay, so it's 0.097, right?
Yes, sir.
Okay. So you see that the value of I1 and I2 is in positive. That means we have decided the path where the current is flowing. We have decided the right path. যে পাথে আমরা কারেন্ট গুলো ঘুরাইছি পাথটা সঠিক ছিল। That's why you have got the positive current. But if I get the negative current, you need not to be confused because at that time the path is just in opposite way. The current is going in the opposite direction. That's it. But you will get the same number, but in the opposite direction you will get minus. That's the difference. But it will not change your mark. The mark you will get the full mark. Okay. Okay. Thank you, boys. So this is the circuit which we have discussed for 2 cells. But tomorrow class, on the next class, we will discuss about the 3 cells, not the 2. We need another class for Kirchhoff circuit. And on that class, we will go for 3 cells. How to solve 3 cells Kirchhoff circuit. Okay. We will go on the next class for this circuit. Okay, thanks. Thanks for today, and we will come back on the next class with this circuit for 3 batteries. Till then, stay home, stay safe. Thank you.
Sir, Assalamu alaikum, sir.
Walaikum salam. Allah Hafiz to all.
Assalamu alaikum.
Walaikum salam.
Assalamu alaikum, sir.